Okay, this is number 7 in the sheet regarding magnetic fields created by currents. Let's try to figure this out. The figure below shows two very long wires, each carrying a current of 4.1 ampere directly out of the page. D1 is this much, D2 is this much, okay? What is the magnitude of the net magnetic field at point P, which lies on the perpendicular bisector to the wire? So that is the same as this. Now B resultant at point P is due to B1 and B2 vectorially. The only problem is we need to figure out the senses of those B's so that we would be able to add them. Now let's assume this is wire 1 and this is wire 2, and at point P, wire 1 would create a magnetic field. Okay, take a look. That would be it. This would be the sense of the magnetic field coming from wire 1. From 2, again, using the right hand rule, right? That would be something as such coming from wire 2. So eventually we'd have this as B1 and this as B2. Okay? We do not know if the angle is 90 degrees. Figures are never up to scale, even right now. Okay? How do you figure out this angle? Well, let's first calculate B1 and B2. That would be a very easy job. B1 is a magnetic field created by a current traversing a wire, so it's mu0 over 2 pi I1 over D1. And D1 in this case, it's not the D1 given, it's that distance. Let me erase this. Sorry. Okay. It would be that distance which I care about. Okay. This is the distance I care about. mu0 is 4 pi times 10 minus 7 over 2 pi. I1, they've said they carry a current of 4 ampere over D1. D1 is the square root. If you follow Pythagoras, if you just deal with that, and D1 is 6.24 over 2, and that is 4.06. Okay, so that would be 6.24 over 2. Remember, that is in centimeter. That would be squared. Okay, plus the second distance, 4.06, also squared. And all of this I have to change into centimeters, or you just grab a calculator and change them and do the math. It would be way easier. And then that would be in Tesla. And then B2, it's again mu0 over 2 pi I2 over D2, and basically it's the same thing since they carry equal currents over 2 pi, and since they are located on the perpendicular bisector, then that distance is the same as this distance. So everything we've written over there, okay, in Tesla. Basically we would have the same value for those B1s and B2s. Now how do I figure this angle out? Okay, so go back here. All you have to do is figure just one angle. Okay, this angle, for example, let's call this angle alpha. So tan alpha, simple trigonometry, is opposite, which is this part, D1 over 2, which is 6.24 over 2, over adjacent, which is D2, 4.06. Now let me try calculate this. 6.24 divided by 2, we divide by 4.06, and that would be 0.768. So alpha would be tan inverse shift tan this answer, and that would be 37.5 degrees. So this would be 37.5 and that would be 37.5. So I care about that angle, 37 and 37, that would be 75. So that must mean this is 105 degrees. So 105 degrees, how would I be able to find the resultant of those two? So coming over here, this is B1, this is B2 at 105 degrees. Do I need the resultant? Just trace, complete the palm, and that would be B resultant. According to cosine law, BR squared equals B1 squared plus B2 squared, and plus, this is the adapted rule, B1, B2, cosine the angle in between them. Okay, we have B1, we have B2, and all you have to do is figure out BR in Teslas. Okay, hope that did the job.